ISCP Awareness Training, Step 5. Step 5. Develop an Information System Contingency Plan. Plan development incorporates the BIA findings and documents recovery strategies. There are 5 main components of a contingency plan. We will look at each component individually. The supporting information and planned appendices provide essential information to ensure a comprehensive plan.
Supporting information includes an introduction and concept of operations sections providing essential background and contextual information that make the contingency plan easier to understand, implement, and maintain.
Introduction. The introduction section orients the reader to the type and location of information contained in the plan. Generally, the section includes the background, scope, and assumptions. Background. This subsection establishes the reason for developing the ISCP and defines the plan objectives. Scope. The scope identifies the FIPS 199 impact level and associated RTOs, as well as the alternate site and data storage capabilities as applicable. Assumptions. This section includes the list of assumptions that were used in developing the ISCP, as well as a list of situations that are not applicable. Concept of operations. The concept of operations section provides additional details about the information system, the 3 phases of the contingency plan, activation and notification, recovery and reconstitution, and a description of the information system contingency plan roles and responsibilities. System description. It is necessary to include a general description of the information system addressed by the contingency plan. The description should include the information system architecture, locations, and any other important technical considerations. System description. An input-output diagram and system architecture diagram, including security devices, firewalls, internal and external connections, are useful. Roles and responsibilities. Presents the overall structure of contingency teams, including the hierarchy and coordination mechanisms and requirements among the teams. The section also provides an overview of team member roles and responsibilities in a contingency situation. Roles and responsibilities. Teams and team members should be designated for specific response and recovery roles during contingency plan activation. Overview of 3 phases. The ISCP recovery is implemented in 3 phases: activation and notification, recovery, and reconstitution. We will now consider the activation and notification phase. The activation and notification phase defines initial actions taken once a system disruption or outage has been detected or appears to be imminent. The ISCP should be activated if one or more of the activation criteria for that system are met. If an activation criterion is met, the designated authority should activate the plan. At the completion of the activation and notification phase, ISCP staff will be prepared to perform recovery measures to restore system functions. Activation criteria may be based on extent of any damage to the system, physical, operational, or cost, criticality of the system to the organization's mission, critical infrastructure protection asset, and expected duration of the outage lasting longer than the RTO. Notification procedures. An outage or disruption may occur with or without prior notice. The procedures should describe the methods used to notify recovery personnel during business and non-business hours. Prompt notification is important for reducing the effects of a disruption on the system. In some cases, it may provide enough time to allow system personnel to shut down the system gracefully to avoid a hard crash. A common manual notification method is a call tree, as shown.
This technique involves assigning notification duties to specific individuals who in turn are responsible for notifying other recovery personnel. The call tree should account for primary and alternate contact methods and should include procedures to be followed if an individual cannot be contacted.
Outage assessment. Following the outage or disruption, notification should be sent to the outage assessment team so that it may determine the status of the situation and appropriate next steps. The outage assessment should be completed as quickly as the given conditions permit, with personnel safety remaining the highest priority. Outage assessment procedures may be unique for the particular system, but the following minimum areas should be addressed. cause of the outage or disruption, potential for additional disruptions or damage, status of physical infrastructure, structural integrity of computer room, condition of electrical power, telecommunications, and heating, ventilation, and air conditioning. Inventory and functional status of system equipment, fully functional, partially functional, non-functional. Type of damage to system equipment or data, water, fire and heat, physical impact, electrical surge. Items to replace, hardware, software, firmware, supporting materials, and estimated time to restore normal services. We will now consider the recovery phase. Recovery phase. Formal recovery operations begin after the ISCP has been activated, outage assessments have been completed if possible, personnel have been notified, and appropriate teams have been mobilized. Recovery phase activities focus on implementing recovery strategies to restore system capabilities, repair damage, and resume operational capabilities at the original or new alternate location. When recovering a complex system, such as a wide area network or virtual local area network involving multiple independent components, recovery procedures should reflect system priorities identified in the business impact analysis. The sequence of activities should reflect the system's maximum tolerable downtime to avoid significant impacts to related systems. Procedures should be written in a stepwise sequential format so system components may be restored in a logical manner. Recovery procedures. To facilitate recovery phase operations, the ISCP should provide detailed procedures to restore the information system or components to a known state. Recovery procedures should be written in a straightforward step-by-step style. A checklist format is useful for documenting the sequential recovery procedures and for troubleshooting problems if the system cannot be recovered properly. We will now consider the reconstitution phase. Reconstitution phase, the third and final phase of ISCP implementation. It defines the actions taken to test and validate system capability and functionality. During reconstitution, recovery activities are completed and normal system operations are resumed. If the original facility is unrecoverable, the activities in this phase can also be applied to preparing a new permanent location to support system processing requirements. This phase consists of two major activities: validating successful recovery and deactivation of the plan. Validating successful recovery typically includes these steps. Concurrent processing. Concurrent processing is the process of running a system at two separate locations concurrently until there is a level of assurance that the recovered system is operating correctly and securely. Validation data testing. Data testing is the process of testing and validating recovered data to ensure that data files or databases have been recovered completely and are current to the last available backup. Validation functionality testing. Functionality testing is a process for verifying that all system functionality has been tested and the system is ready to return to normal operation. Deactivation of the plan. Deactivation of the plan is the process of returning the system to normal operations and finalizing reconstitution activities to prepare the system against another outage or disruption. Deactivation activities include notifications. Upon return to normal operations, users should be notified by the ISCP coordinator or designee using predefined notification procedures. Cleanup. Cleanup is the process of cleaning up workspace or dismantling any temporary recovery locations, restocking supplies, returning manuals and other documentation to their original locations, and readying the system for another contingency event. Offsite data storage. If offsite data storage is used, procedures should be documented for returning retrieved backup or installation media to its offsite data storage location. Data backup. As soon as reasonable following reconstitution, the system should be fully backed up and a new copy of the current operational system stored for future recovery efforts. This full backup should be restored with other system backups and comply with applicable security controls. Event documentation. All recovery and reconstitution events should be well documented, including actions taken and problems encountered during the recovery and reconstitution efforts. An after-action report with lessons learned should be documented and included for updating the ISCP. We will now consider the appendices. Appendices. Contingency plan appendices provide key details not contained in the main body of the plan. Common contingency plan appendices include the following: contact information for contingency planning team personnel, vendor contact information, including off-site storage and alternate site POCs, business impact analysis, detailed recovery procedures and checklists, detailed validation testing procedures and checklists, equipment and system requirement lists of the hardware, software, firmware, and other resources required to support system operations. Details should be provided for each entry, including model or version number, specifications, and quantity. Alternate mission business processing procedures that may occur while recovery efforts are being done to the system. ISCP testing and maintenance procedures. System interconnections, systems that directly interconnect or exchange information, and vendor SLAs, reciprocal agreements with other organizations and other vital records. This concludes ISCP Awareness Training Step 5. To continue, click on ISCP Awareness Training Step 6.